Hello and welcome to another Cashmatics video. In this session what we'll be looking at is integrating standard functions. But in order to understand these we need to make sure we understand the derivatives of certain functions. So I'm just going to go over a few derivatives to begin with, and there's my first lot. So what we're going to do first of all is just look at the derivatives of these. Now you should have already done these when you're looking at differentiation, but I'll go through them anyway. So the derivative of x to the power n, you multiply by the power, so that's n, and then take 1 off the power, so x to the n minus 1. The derivative of e to the x is just e to the x. The derivative of the natural log of x, that doesn't quite look like the natural log of x, let's just change that. So ln of x is equal to 1 over x. Sine x becomes cos x, and cos x becomes minus sine x. Now, I can look at these derivatives to help me with the integrals, because the integration is just the opposite of differentiation. So if I wanted to integrate x to the power n, it's just the opposite of what we've done. So if you multiply by the power to differentiate and then take 1 off the power, I need to do the opposite. So I need to add 1 to the power, then divide by the new power. So the integral of this would be x to the power n plus 1 over n plus 1, and you have your constant of integration afterwards, which you should already know about from your basic integration. E to the x will just become e to the x plus c. Okay, it's just they're exactly the same. So if that differentiates to become that, then that'll integrate to become that. The integral of 1 over x dx is the natural log of x, and don't forget to put the x in modular signs, plus c. And the reason why we do that is because when we're integrating with limits, if the limits were minus 2 and minus 3, you'd actually put 2 and 3 when you were working out the absolute value of that, or what would you call it, the definite integral. Now this one I've got to be careful with. Sine x becomes cos x, so cos x becomes sine x, so that would be sine x plus c. And the last one, cos x becomes minus sine x, so the sign changes for this one. So when I do sine x, I'll have to change the sign when I go backwards to make minus cos x plus c. Right. So when it comes to these integrals, what a lot of people struggle with is finding them in the formula book. Now, quite often you have to look at your derivatives section in the formula book in order to work out what the integrals are. Okay, so be prepared to look at the actual derivatives for your to help you with the integrals. Right, so those are the first 5 functions. Let's look at a few more. Right, these ones here. So again, when you were doing differentiation using the quotient rule, you might have been asked to try and differentiate this function here. So you would have rewritten it as sine x over cos x and then differentiated it using the quotient rule. But when you do differentiate it, you end up with sec squared x. Okay, sec x becomes sec x tan x. Cot x becomes minus cosec squared x, and cosec x becomes minus cosec x cot x. Now, although these are all in the formula book, what you've got to make sure of is that as soon as you see them, you recognize them, okay? Because you might not think to look in the formula book. You know, you might look at sec x tan x and try and manipulate in some way to get something which you recognize without realizing this is like a standard integral, okay? So make sure you actually practice these. You try to commit as many of these to memory as you can, and you're only using your formula book as a way to double check what you're doing rather than using it to actually find out whether you can integrate or differentiate something. It's much easier to have these in your mind, ready to use, and only using the formula book as some kind of verification, because you might just miss it and you might not think to look in your formula book. Anyway, so how can we use these to integrate? So if I wanted to integrate sec squared x, that would give me tan x. If I want to integrate sec x tan x, I get sec x. If I want to integrate cosec squared x, now look at the change of sign here, that would be minus cot x. And if I want to integrate minus cosec x cot x, again look at this. Sorry, if I want to integrate cosec x cot x, again look at this change in sign, that would be minus cosec x. Hang on, let's rewrite that. Cosec x plus c. Alright, so those are your standard integrals. Now, if I was you, I'd probably pause the video at this stage and copy down that list of integrals and the one from the previous slide, so we can move on. So make sure you got those to hand, and they will help you when we start looking at some examples. So here's our first example, the integral of 3 sec squared x plus 5 over x plus 2 over x squared. So let's just look at what we've got. We're just going to break it down a little bit. So we can see we've got a sec squared x there, okay, and that appears in our integral list. Okay, remember that's the derivative of tan x. So when I integrate this bit, I'm going to get tan x. This is 5 lots of 1 over x. Okay, so again we've got 1 over x, which we can integrate to give us ln x. And here we've got, well, we've just got a normal power, so let's just rewrite that as 2x to the power minus 2. Okay, so this is what we're going to be dealing with. So let's just rewrite it neatly. So we've got the integral of 3 sec squared x plus 5 over x plus 2x to the power minus 2 dx. So from here it's actually quite straightforward now. So sec squared becomes tan, so that would be 3 tan x plus 5 lots of the integral of 1 over x. The integral of 1 over x is ln x, so it'd be 5 ln x plus, in this case here, you add 1 to the power and then divide by the new power. So it'd be 2x to the power minus 1 divided by minus 1 plus c. Okay, and we just need to tidy that up. 3 tan x plus 5 ln x, take away 2x to the power minus 1, add c. Okay, next example. Let's see what we've got here. We've got a cosec x cot x. So like I was saying, it's useful to have these in your head, so as soon as you see them, you recognize them. Okay, so this here, you should recognize from the integral table. This you should definitely recognize because it's the same as the last example. So this shouldn't actually be that difficult. So let's just look at it. Okay, so cosec x, when you differentiate it, becomes cosec x cot x. So when I integrate this, it'll be minus cosec x. So that'll be minus 2 cosec x. Take away, now the derivative of tan is sec squared, so the integral of sec squared is tan. So it'll be take away tan x plus c. Okay. The thing I see some students trying to do is manipulate this part of the expression, this cosec x to cot x. So they split the cosec x up, they rewrite the cosec x as 1 over sine x and the cot x as cos x over sine x, and then try and do something with it, with the sines and the cosines, and try to integrate it that way. Okay, and I mean that can send you all over the place. Okay, so just make sure as soon as you see cosec x cot x, you're thinking, right, okay, that's something to do with cosec x, and then just look at your formula book if you need to, and make sure you get the sign right. Right, let's have a look at this example then. Now this does look a bit horrible, okay, because you've got sec squared x, you've got an e to the x, you've got a cos squared x, and it's all in brackets, and it just doesn't look nice. But when you come to doing it, you'll actually find it's not too bad at all. Okay, so whenever you see brackets like this, the first thing you do is just, well, not always, but the first thing that's worth trying is actually expanding the brackets. So let's just do that. So that would become the integral of sec squared x plus e to the x cos squared x sec squared x dx. Now, what makes it easy is the fact that sec squared x, this here, is just 1 over cos squared x. So that will actually cancel that out. So the integral actually becomes the integral of sec squared x plus e to the x dx, which is now quite simple. So hopefully you recognize that sec squared x becomes tan x, so tan x plus e to the x, which just becomes e to the x, plus c. So that's the integral of that function. Nice and easy. Right, and one last example here. Now this one doesn't look nice at all. We see things we recognize, but the way they're written, it's not really very helpful. So what we need to do is first of all manipulate what we've got here to help us get it into a form where we've got lots of different terms, each of which can actually be integrated using our standard integrals. So this, for example, this here doesn't appear in our integral list, okay, and neither does this, okay. But what we can do is we can split this fraction. Okay, so 1 plus sine x over cos squared x, so that's like dividing each of these individually by cos squared x. So I get 1 over cos squared x plus sine x over cos squared x, add cos squared x sec x, so cos squared x times by sec x, which is 1 over cos x dx. Alright, now this here cancels out the square there, so that term's quite nice now because that just becomes cos x, so we know we can deal with that. 1 over cos x is sec squared x. Okay, this second term, sin x over cos squared x, I can write as sin x over cos x times by 1 over cos x. Let's just write this third term, cos x dx. Okay, now this, just leave this as it is, so sec squared x plus, now look, this is sin x over cos x is tan x, 1 over cos x is sec x, so I've got tan x sec x, or I can write it as sec x tan x plus cos x dx. So what I've actually got now is lots of terms I can actually integrate. Sec squared x, that's turned up loads, that becomes tan x. Sec x tan x, you should recognize that. If you look at your list, you should see that as the derivative of sec x, and cos x is the derivative of sin x. So I can write my final answer now. So my final answer, let's write it over here, my final answer becomes tan x plus sec x plus sin x, add c. Okay, so that's my final answer. So hopefully you've understood how this works. Okay, it's the standard integrals. They're all in the formula book. In some they'll be in the differentiation section. You just have to look at those in order to work out the integrals. And in some, you'll see them in the integration section as well. And sometimes you'll see them in both. But just familiarize yourself with them. Learn how to manipulate the functions to get them into a form that you actually know how to integrate. And then the rest of it is actually quite easy. So I hope that's helped. So see you next time.